Okay, so now let's look at a problem. This is HC Verma chapter 8, problem 40. So we have a body going down incline from point A to point B. Initially it's at a height of 1 meter. It goes down by 0.2 meter, reaches a height of 0.8. So the question is, what is the work of the friction force during this time, right? So let's apply the work energy theorem over here. So we have the work of the non-conservative force equal to delta E, right? Of course, in this setup, so when the mass goes along this incline at any given point in time, we have three forces, right? So we have mg in this direction, we have the normal force in this direction, we of course have the friction force in this direction. Now, the normal force itself does zero work because at every given point in time, the normal force is always perpendicular to the motion, right? So it's always zero. The mg force is already accounted for as an expression for the potential energy, and so the only non-conservative forces in this setup is the friction force. So we have the work or the friction force is equal to the change in the mechanical energy of the system. So of course we have the condition that the initial and final position is zero. So therefore we have Ke final minus Ke initial plus Pe final minus Pe initial. Now this is zero of course because initial and final velocity is both zero. So finally we have mg times 0.8, right? That's the final height minus mg times 1 meter, right? Now, if we take g as 10, which normally we do in the case of HCF AMA, so we have 1 into 10 into 0.2 negative, that's worked out to minus 2 joules.